Hello everyone, I am Vivek Raja, organizer of AWS User Group Madurai, and welcome to today's second episode of AWS Cloud Practitioner Bootcamp. So today we have Ganesh, who is a AWS Cloud Engineer specialized in security, networks, and organization services. He's 10 times multi-cloud certified and a postgraduate in cloud computing. He's very interested in learning and he loves to share knowledge with all of us. So in today's session, we'll be actually seeing about IAM and shared responsibility model. And over to you, Ganesh.
Thank you, Vivek. Hello, all. Today, I'll be discussing about Identity and Access Management Service. IAM service would probably be the first service everyone will be using because, you use your email ID to create your AWS account, which is called the root account. And AWS strongly advises to create an IAM user so that you can administer all your other tasks. So we will start off first with what IAM is. So in simple terms, we can tell IAM it encompasses or it provides authentication and authorization for the services. So what do you mean by authentication? So authentication is nothing but to confirm who the user is there. For example, let's say while logging into this YouTube, you would have provided your username and password. So that is one form of authentication. And it is not just that, but you can also have, say, verify through your OTP messages, or even you lock or unlock your phones through biometrics or patterns. So all these stands for authentication. So it verifies that whatever person who is telling, so that is what they are. And next is authorization. So once it is proved that the person is the who they claim to be, next the authorization part will give whatever access that particular person or identity is entitled to. Let's take a simple example where you log into a Hotstar application. If you are a VIP user, then you will be able to watch only the free episodes and the VIP episodes. But if you are a premium user, you can watch VIP free as well as the premium episodes. So this is a simple example of authorization where, based upon your access level, you will be provided access to different services. So similarly, in AWS, so we they also provide an identity and access management service, and it is kind of a core service where for any solution you will be using these services in one shape or one form. So these are the key identities that are present in IAM, and I will be going through all these one by one. So this is more the IAM user, so it will be more of an hands-on where as I will go through the console and explain you the concept as well as how it is being created. So there isn't any slide as such. So first I will let me share my console and we'll start with IAM users. Okay, so now I am into my IAM AWS account, and you can search for IAM services. And here we can see, so the users are roles and user groups, so they are all called as identity, which is nothing but when you create them, you can use it for authentication for user groups. So first we will start off with AWS users. So users in this section will be able to create a user identity for accessing the application, or we can say AWS services. And these users accounts need not be human accounts. Say for example, Ganesh. So this is my username, and as a human, I am able to log in within using this particular credential. Apart from this, we can also create other accounts which are service accounts or non-user accounts, non-human accounts. So what does mean is, say for example, we are integrating this particular AWS service or our application in AWS with a monitoring tool like say Splunk or Datadog. Then we can create a user account for that particular application or external service. We can create a user account here and provide the relevant access. So first we'll start off by creating a user. So we'll click on add users. We will give a username. I'll go with developer one. And there are two options to provide with. Either you can provide a programmatic access or a console access. So console access, so we can access the AWS services in a multiple ways. So one is the console, like how I log in using the console.aws.amazon.com URL, and other is programmatic access, where you can use CLI, nothing but command like interface, or your software development kit or any IDE. So for that you will use programmatic access, and for logging only through console, we will be having the console access. So let me select both of them, and you have an option for a console password, whether it is auto generated or you can set a custom one. And you can also give an option where once you set the password, it is like the user on their first login, they should rotate it. So for now I am removing it. Next, permissions. So permissions allows you to give the access for this particular user, but I will be explaining it in detail within after in a short while. So for now, I'm skipping this without providing any permissions to this particular user. And the next one is on tags. So tags are nothing but a name value pair, which will be helpful for you to identify this particular user. And it is not just restricted to IAM. It will This tag value can be tagged to any AWS services, and it will be useful for identification. So we will just in the context of IAM user, you can have say the mail ID of this particular user is some ganesh.ganesh.com. I can give random, but yeah, so this way you can kind of, if you want to add any kind of metadata, you can add to this particular tags. And finally we will be reviewing whatever actions we have done so far. So it is so whatever details we have provided in 1, 2, and 3 steps, so we will be reviewing it here. And then finally we will creating a user. So here you can see, so since we have asked for providing console access as well as CLI access, we are being provided with the key ID and secret key along with the password. And this is only you will be able to get the details only now. If we close this without saving these details, then these details are lost and we need to create a new one from again. So for now, I will download it so that I can refer it later. So now we'll close it. So now we have created a new user called developer one. So now what I will do is I will log in. So this is my root account I have logged in. So now I will log in as a IAM user. So to log in as an IAM user, if you see the if you see here, so they themselves will provide a link. So usually it will be the account ID here, but I have provided an alias and hence I have a link like this. So that is fine. So what you can do, you go back to again console.aws.amazon.com, and here you will ask for your account ID. So since I have a alias name, I can give that. If not, we have our account ID here. So here you can always get your account ID and you can provide that. Next, the username which I have created, that is developer one. Then the password. So now I have logged in as a developer one at the rate of my account. Now let's say if I go to again the IAM services, you can see I don't have any permission to view any user groups of any of the thing within IAM. It is not just IAM. If I go to any other services as well, I will not be able to view because no permissions is given to this particular user. So by default, if you just create a user, they will not have access to any services within AWS. We need to provide permissions. So let me go back to the root user. And for permissions, we have something called here as in AWS as policies. So policies defines permissions which can be attached to either a user or a user group or a role. So policies are there are two types of policies. So one is a managed policy, another is an inline policy. Let me go to the example here as a developer one. Here you can see add an inline policy. What this means is if I provide any policy or any access permissions to this particular user, it is restricted only to that user. So for example, let me give access to S3. I will explain about all these shortly. So this policy is created which provides access to S3, but it is something local to this particular user. You can't use this policy to some other user or some other groups. So that is called as inline policy. There is another thing called as managed policy. So here you can see attach existing policy or create new policy. So what managed policy means is you can create a standalone policy which can be used or which can be reused by for more than one identity. And there are two types of managed policy. So you can see here, one is a custom managed policy, which means say I am clicking here create policy and I'm typing everything and saving it. So that is a managed policy, customer managed policy. And AWS out of the box, they provide a list of access or permissions. So that are called as AWS managed policy. So by the type difference, you can see whether it is a customer managed or AWS managed policy. So let me go with AWS managed policy and say I want this particular user to have access to S3 because they want to store some of the files they have created. So if I search with S3, so here you can see the various policies provided by AWS. So if the user just needs read only, you can have read only. Full access provides read as well as write. So similarly, each policy provides a set of permissions. So I will select S3 full access. Okay, I was just selecting here. So let me go back to the user and then let me add the policy. So add permissions, attach existing policy, and then S3 full access. And it is not just that you can only link one policy. As you can see, it is a multiple select. So you can select for other policies which are required for this particular user, and then you can add it. And AWS recommends or the best practice is that you should provide a least privilege. So what does mean is, for example, in this policy we have given S3 full access, which means it is able to read, write, and list all the objects. But for example, this is okay for a developer who wants to store files and then retrieve it. But if say there is a team lead or a manager who just wants to know what are the files stored in it and just view it, then instead of providing S3 full access to them, you can provide a read-only access to them so that they can just view the files in it. So that way, the access is provided only for that particular specific requirement, and this will help in minimizing or mitigating any risk that can happen in future. So in policies, so now we have seen what is an inline policy, and in managed policy, what is a customer managed policy and AWS managed policy. Now I will show you an example of how a policy or what is a policy structure is. So version, so this is the full structure of a policy. So first it starts with the version, like what is the version of the policy document which we are being specifying. Next statement. Statement is a container of permissions that we are going to specify. And our first policy, it starts here. So this is the first policy which we are specifying. It starts with a statement ID where you can provide human readable like what this particular access provides. For example, I can say S3 full access. So by reading it, we can understand, okay, this particular policy is providing the full access through S3 service. The next, the effect or what is going to be there. whether it is allow the service or deny service. So only two values are allowed. If you deny service, then this particular user will not be able to access the S3 service, or will not be able to perform the actions which we are going to call out here. Allow means it is going to allow the services. So by default, all the explicitly, if we say, for example, if I provide a deny here, so which means explicitly we are denying access to these buckets for this particular, or to any user this policy is attached. So how the policy evaluation works is, if there is an explicit deny, then whatever, if there is an allow in some other policy also, it will not be working, it will be fully denied. But if there is an allow, then if it will allow those services. So now we'll go with allow. Then next is principal. So principles, there are mainly two type of principles we can call out, and which is nothing but what kind of resource that can access this particular resource. So one is AWS, we can mention, and we can call out the IAM user. So this is an IAM user here. So we can call out which IAM user needs to be here. So it can be a user or a role. And another is service. So we can tell here as service, and we can mention here is a, say for example, there is a service called config. So we service will be allowed to access these particular resources. So there are two type of principle usually we'll define. Either it is an AWS, which is for roles or IAM user, and service for service like config, cloud trail, etc., which we'll be discussing later. Then next comes action. So in action, here if we mention S3 star, it means like we are allowing all actions or all permissions related to S3 to this particular user. If we go here programmatically, and if we see, let's say I am creating a new policy, you can see here. So again, let me select S3. So I am selecting what service I am using, and in that what actions. So we have there in that policy we have provided star, so it provides S3 star. But let's say if we want to just have user to only read, so read in usually involves read and list. So in that case, what will happen? It will be only having read and list permissions, and we can see the JSON here. Let me select the resources. Here you can see. So all the list and get operations alone. So these are all individual permissions related to S3 that are getting tagged to whatever user linked to this. So this is on actions. And finally resources. In resources, if we tell it is a star or a wild character, it refers that all S3 actions to all S3 buckets this particular user will be able to access. But if we restrict by providing the ARN, or ARN stands for Amazon Resource Name, it is kind of a unique ID that is provided to each and every resource within AWS. So if we, this is the ARN for an S3 bucket. So if we provide such individual bucket names, so that means this particular user to whom this policy is attached, they can only access that particular bucket alone. Even if we have another bucket, they will not be able to access it. So that kind of restrictions we can put in this resource. So yeah, so this is the overall structure of this. So you can use to create this JSON file like this, or you can also use the visual editor and you can edit it and it will reflect here. Or you can copy the content in JSON here and you can verify in the visual editor. So both you can do. So that is on policies. So now in our developer one, let me delete this inline policy. So now we have provided S3 full access. If we go to here, so IAM, it doesn't have access. So let's search for S3. Yeah, you can see now it has access to all the buckets because we have provided access. So on these actions are instantaneous. You no need to say log out of the user or log in or do anything. It is instantaneous and it will be immediately reflecting. So now we have seen a user. Now and we have seen policies. Next we'll go to user groups. So let's say now a new person has joined the team, and let's call developer 2, and they have programmatic access. And again, if you see, since they are from the same team, so they again need to access the same S3 bucket alone. So again, we'll be creating the user. And so every time like this, if we create, if a new users are joining, then each and every time we need to kind of tag the permissions and everything to the user. And once they go off, it may need to be removed again. And so this is kind of a cumbersome process, I would say. And it is also not a best practice to link permissions directly to the users. So that's why we have something called as user group. It is nothing but a set of users. Say for example, we have two developers here. So what we can do, we can create a developer group. And if a user is already available, you can select it. If not, once users are created, you can add it manually later. And then you can attach the permissions directly here. So the S3 policy, and if I give click create, so hereafter, if I need a new person, so here you can see we have developer 1 and 2 within this group, and this particular group has permissions to S3 full access. If you go to developer 1, you can see here. So one attached directly, we have this, and another attached from group. So whatever access that is being tagged to the group, it will automatically be inherited by the users present within that group. So what you can do is, rather than providing permissions to individual users, you can create groups like this. For example, then next, if you have a server administrator, then you can create a group called server administrator and provide only access to say EC2 and relevant services. Like that, if you have groups and access defined to it, so whenever a new person comes to the team or whoever leaves the team, so you just need to create the login for them and just the credentials. So by attaching to this group, they'll be having access, and once they leave, you can just remove it. So that way, even if for say for a temporarily, if there is no team or there is no requirement, still the group will be present, so that next when again a new team comes in, you can just reuse it. And AWS suggests to use groups and attach permissions to the groups rather than attaching it directly to the user. So this is about user groups. So it is again just the same, it is but a combination of everything. And finally, we have something called as roles. Role, how we can give an example is, say for example, we have an application running in EC2 instance within a VPC. So that particular application, the data is going to be stored in a database. Let's say Aurora, AWS Aurora database. So ideally, what we need to view, or let's say it is storing some static data in S3 bucket. We'll go with the same example where S3 bucket. So if we want that particular application to access the S3 services, we need to provide the credentials. So we have seen that programmatic access, right? The access key and secret key. So we should be providing that within the application, so that the application can use that, and it can access the S3 to say store a file or read the file. But storing an access key in a code is a big no. So it will be a very big risk, and it is not at all such advisable. So what we can use in that case is roles. So a role, what it does is, it is again similar to user or user groups, I can say, where you will be creating a identity or entity that is attached to a particular permissions, but you will tell that this particular role or this particular active action can be performed only by a, you say, EC2, or whomever you want to trust, only them they can perform it. So that is one way to use the roles. And another way is, say for example, this is one account which you are managing, but there are multiple accounts within your organization which you are managing, and one application in that other account needs to talk to the S3 bucket in your account. Then rather than giving the credentials of this particular creating a user here and giving credentials, what you can do, you can just create a role, and you can trust to that account, so that whatever application is running in that particular account, they can use that role or assume that role and access the S3. So if we click create role, so here you can see the trusted entity type is nothing but what you are allowing to trust, or what service or what identity can assume this particular role. If we tell AWS service, then services like EC2, Lambda, or there are other services which can which are allowed to assume this role. Or if you tell AWS account, then either you can give account directly, so that you can give the account number here directly, or you can even give the exact ARN of the username who is going to assume this role. And there are other, say, once you have this federation or SSO, you can even allow them. So for this example, we just simply go with AWS service, and let's say any EC2 service that is running within this particular account, they are allowed to assume this role. And next, we can see same thing, whatever we have seen. So this is a permissions policy. So whatever permissions, you can have a fine grained again. So by custom policy, you can have a fine grained where only, say for example, this application is only going to write the data and not read data. Then rather than providing AWS S3 full access, you can just provide access to write related permissions like put object, etc. And we will provide a role name. We'll say EC2 role, and here you can see allows EC2 instances to call AWS services, in this case S3 services, on your behalf. And this is the trusted entity, so once created I will show that. And this is the permissions which you have added, and tags we can add it. So roles have been created, and we will check for our role EC2. So this is the EC2 role which we just created now. And here you can see, as usual, the permissions, whatever permissions we have tagged, it will be here. And the trust relationship, which particular service or account which we have trusted to assume this role, it is provided here. So like it mentioned, since it is a EC2 service, the principal is service. If you have provided an account, it will be account and the account number, or the root ARN, and the action. So what this action is, like this STS assume role. So this is the action that will be, or this is the permission that is needed for this particular EC2 service to assume this role. So for any services, so this STS assume role will always be tagged to it. Okay, so these are the details about users, user groups, roles, and policies. So if you have any queries, just type in the comment, and once the session is completed, so we'll clarify on that. So if we come back to the presentation here, so we have seen users, groups, policies, and roles. So next we'll move on to multi-factor authentication. So here you can see, as a developer, I just logged in with my credentials. It didn't ask for any second factor or multi-factor authentication. So now, but it is a best practice to always have a two-factor authentication at least, so that your account is not compromised. So we'll go back to our IAM service here, and let me go to the developer one. In the security credentials tab, so you can see console password. Say for example, now that particular user is telling he is unable to log in.
Hello,
Then as an administrator,
Ganesh.
what you
One
can do
second.
is,
I guess your screen is your screen is actually frozen.
is it loading now?
Mm, One second. Let me try adding you back. Your webcam also seems to be a little bit frozen. So what I will do is I will remove your presentation from the screen. I'll add it back, and you try to again reshare your screen from first.
Okay.
Yep. If possible, you can also turn off your camera if there is any bandwidth issue. But
So is my
yes,
screen visible?
yeah, now it's visible. Yep.
How about my cam? Is it okay?
Uh, Let me try adding you back. I guess now it seems better. So yes, we can proceed.
Okay, thanks. Yeah, so we were discussing about multi-factor authentication. Uh, when, say, for example, we have our user one, and as an administrator, if this particular user is has left or has on a long holiday, you can disable it, and once they are back, you can enable. Or you can also reset the password, because if they forgot, then only as an administrator, only you can set the password. And similarly, another action which can be performed is an assign an MFA device. So what this means is, once a user provides your password, so like how during a banking transaction you will provide a captcha test or verify by OTP. So similarly, you will be providing a six-digit code either from a hardware token key or a software token key. So there are options like hardware token key, where physically hardware token will be with you, and you can check the code from there and key in. But mostly we'll go with virtual MFA device, where you can use apps like Google Authenticator or Microsoft Authenticator, etc., to authenticate your device. So let's say I'll click continue, and I will provide I will open the Google Authenticator in my phone, and I will scan this particular QR code. Then it will start populating six digits for me. So I need to provide code 1 and then code 2. And once that is done, if I click assign MFA, it will be completed. So rather than completing this, what I will do, I will sign off and log in back again as a root user, because I have already configured it for my root user. So if it is an IAM user, you can click this, provide your account ID and do. So as a root user, first it will ask for CAPTCHA, then the usual password.
Sorry to interrupt you, Ganesh. So, is it possible for you to turn off your camera? I guess your video stream gets stuck in between.
Yeah, no
Yep.
problem.
Yeah,
I
sure.
have
Thank
closed
you.
it. So I have keyed in my password. So this is the first form of authentication. So now it asks for the MFA code. So going to the Google Authenticator, and it will keep on changing the password or the digits. So every 30 seconds, the digits gets changed. So we just need to check what is the being displayed currently. And if we click in, so yeah, we'll be logged into the console. So this is how you can assign a MFA or a multi-factor authentication to particular user. Next, we will check on CLI or command line interface access. So far we have logged in as a in a console, and then we have created everything. So we'll now try to access using or logged in as a CLI and check it. So for that, what I will do for developer, I will provide access to IAM. Currently it has S3, so I will also give access to IAM so that it is able to create some users for us. So I am providing IAM full access, and so immediately it will be reflecting. So now for installing CLI, we can just check in the Google and you will get options. Yeah. So here you have. So you have options like how to you can install the Amazon or AWS CLI or command line interface for Linux. You just need to execute these commands. Or if it is, you also have options for Mac OS and Windows. So I'll be going with the Windows here. So as a first step, we just need to run the Microsoft installer, and it should work directly. So I will open. I will make my clean screen a little bigger, and I will just execute the code. So now just we just need to, like any other software we are installing, we'll be just installing the AWS CLI. So it's completed, and you can quickly check whether it's installed successfully by checking its version. Okay, I need to exit and then log it again. Yeah, so it has been successfully installed. So first, like in console, how you provided username and password to configure. So similarly, we need to configure our current session, and for that, you can just type AWS configure, and it will first ask for the key ID. So as a developer two, okay, let me go to the developer two. Yeah, so here we have the access key to developer two. I will copy the key ID, paste it, connect it to last for the secret key. So I'll copy this. I will paste it. Next, what is the default region name? So most of the AWS resources or services are region specific. If we see here, so we have been into, so IAM is a global service, and hence we see it as global. But if I go back to my console, you can see I'm in North Virginia, which is nothing but US East 1 region. So if you are operating in the same region, fine. If not, if you want to change, you can just type in the region name and give enter. And finally, what is the output format? Say you are executing commands here, and in what format you need, whether it is JSON or, say, for example, in a table format, you can provide that. JSON is fine for me, so I will give that. So now you are ready to access AWS through this. So we will just give a simple command like AWS S3 LS, which will list the buckets that are present in the account. So here you can see it is listing all the bucket names. And if we go here, so the same thing will be here. Yeah. And similarly, we can even create a user. AWS IAM create user, and we are just giving username as say developer 3. So you can see, so developer 3 has been created. And if we go here, so developer 3 is present. So it is not just this one. So say once the account is being created, you have other various API or various commands like add the user to a group, attach policy. So whatever you are performing within the console, so that and even more than that, it can be performed through this command line interface. So this is another way of accessing AWS services. And now you can see, so for accessing this command line interface, what we did is like we installed the CLI tool here, and we were accessing it. Say for example, if you want to have Python libraries related to AWS install, then you need to manually install them and then start using it. So to simplify this, what AWS has done is they have something called as AWS Cloud Shell. So you can see here, so you will see a button here called Cloud Shell. You can do that, or you can also search it here. So this is nothing but a browser-based command line interface, like how we have seen. So you can see here, so it is pre-installed with AWS CLI, Python, Node.js. So all the popular libraries is already installed, and you also get a 1 GB of storage for each region. So what it means is like say once you have created your file, you can store it in your home directory, and you can keep reusing it. So the environment is just setting up. So in a couple of minutes, it should be up. Yeah. So it's been done. So hope you're able to see the screen now. So now the same command, I no need to configure or do anything. So if I give the same command here, it will just execute it. So what happens is it doesn't take the credential of say developer 1, 2, or 3. What it does is whatever user I am currently logged in the console, it takes the credential of that particular user, whatever the access or permissions that particular user has. So it will able to do that. So you no need to key in or do anything. So you can just directly start working in your project. So this is on the Cloud Shell. So in IAM, so we have finally we have some more settings which we'll discuss. So one is access analyzer. So access analyzer, what it does is, like I mentioned, you can create roles which will have access or which trust accounts which trust accounts from outside your current account, or you can also have access to say something publicly. So to analyze all those access so that you know like what is happening. Since this is kind of a POC or my personal account, there are not many users. But when you think in a production scale, so there will be many users using it. So it will not be easy to understand who is having what access and whether it should be restricted or whether it is as expected. So to help that, we have this access analyzer. So we'll just give a name for the access, and we'll give zone of trust. Zone of trust is nothing but, say, if we give current account, what it means is, if any services is providing access to any users or roles within the current account, then it takes that as okay. So this is as expected, and it will not flag it as some warning. If we have our particular organization or our particular account within an organization setup, then we can even call out that whatever accounts or whatever user roles or access provided within that particular organization, then it will not flag it up, and any accounts which has access outside our organization, that will be highlighted. We'll go with current account and create. It is just straightforward. So we'll just give a name and what is our zone of trust, and it will be created. So what happens is, it will like I mentioned, so it will check what all the access provided here, and you can see here. So I have already have some findings, and let's say open one finding. So what it says here is, so this particular resource, it has access or it has a federated user. So something not within this particular account, but the access is federated to some resources outside this particular account. So it is asking, or it is highlighted it. So you can check it and see whether it is needed or not. Say if it is expected, yeah, I know that this particular user or this particular role will have access to this particular external account. I know it, and it is fine. Then you can say click action and resolve it. So it is still scanning, so that's why we are unable to do it at the moment. But yeah, so that's what we'll be doing with this access analyzer. There is a different one called as access advisor. So if you open any user, you can see a final tab called access advisor. So what it does is, like, it will keep a history of what all the actions performed by this particular user. For example, using this developer one, say I log in and just writing the files. So as an I'm just updating, or I'm just uploading the files within S3. Then here you can see what are the, it will say just S3 put object is being used. So using this particular history, you can understand, okay, this particular user is always only using S3 put object permission. So why does this user need S3 full access? Rather than that, I can just give him only just put object access, and I can remove all other unwanted access. So that is what this access advisor does. So whatever access, services this particular user has lost access, it will give you a history, so that from that history you can understand the usage of it to see if this particular user has more permissions than required, and you can remove it. And final setting is credential report. So credential report, you will able to see what is the user credentials. So when was it last used? So this will be able to, this will help you to understand whether the particular user is active or not. If it is not active, then you can just remove it. So you can see the user ARN, when the user was created, whether password is enabled for those users. If password is enabled, that means this particular users have access to management console. If not, they don't have access to management console. So if password is enabled, when was it last used? When was it last changed? And whether if it is any automatic password rotation is present or not. Then MFA active. So whether multi-factor authentication is enabled for that. Then next we have access keys. So there, at a given point in time, any particular user can have two access keys set. So that's why we have access key 1 and access key 2. So the access key 1 settings will be checking whether it is active, when it is last rotated, last used, in which region it is used. and same way for access key too. So how this helps is this will be say for example there are many users within your account, and there is not a proper leaver process, which means that the user, although they have say left your team or left the company, but their user accounts are not deleted from your account, then it will be challenging to manage it, and also it will pose a risk because you are having an active user within AWS, but there is no active actual person in the company. So anyone can use that particular access and access your AWS services. So that's why using this credential report, you can understand when was this past user last access it. So if it is say not in the past 90 days or say 180 days, based on your company policy, then you can disable the account or you can even delete the account. So similarly, if password is user is active, but password is not changed for say 1 year or so, then you can trigger or make that particular user to update their password or change their access key. So this credential report will be beneficial in doing all these actions. Yeah. So back to our presentation. So we discussed about multi-factor authentication, CLI, Cloud Shell, Credential Report, Access Analyzer, and Access Advisor. So this completes the identity and access management services. And so if you have any queries so far, you can put it in the chat, and we will discuss it after the session. So now we'll move on to the best practices. So, the best practices. So some of the best practices I have already mentioned. So, but we'll go through them once. So AWS root account. So the root account user access key you should never set in the first place, and in the worst case, if it is set, then save it somewhere separately, because that part you will not be able to save, restrict the permission or anything to the root account. It has access to all services, everything. So don't use the root user access in the first place. Then create individual users. The same thing. Then next is define policies to assign permissions where possible. AWS defined policies. So the reason being is like AWS keeps updating their managed policy as and when say it introduces a new permissions. So if you use a AWS managed policy wherever, then it will help you to have it your policy updated. Then use groups to assign permissions users. So like we discussed, you should always assign permissions to the groups rather than individual users, and grant least privilege. Then use access levels to review IAM permission. So we like we have seen the access advisor. So what exact permission that particular user is needed, you can give only that, so that there aren't over permissionly user. Then configure a strong password. Yeah. So on this point, I can quickly show you on strong password policy. So we have account settings here, and here you can see we can define the password policy for a particular account. So you can enforce the minimum length. So 6 is not ideal. So AWS recommends 14 characters, and you can enforce whether it there should at least be one uppercase letter, one lowercase. It should have one number, one character, and you can also even enable expiration, and usually AWS suggests 90 days expiry. So that is kind of the minimum which they suggest. So every 3 months or once in a quarter, the user should be able to rotate the password. Next, if a password expires, do we require administrator reset? So ideally, we wouldn't need some other person to come in and reset. So the user themselves should be able to reset. So that's why we select here, and then prevent password reuse. What this means, say for example, you set the password as password, then say after next time also you will not be allowed to set the name as password. You change it something else. So like that, remember 5 times password means, so last 5 passwords you will not be able to set it. So that is what this prevent password reuse means, and AWS actually suggests 24. So last 24 passwords, it should you shouldn't be able to set it. So that's what AWS recommends. So now back to the slide. So yeah, so this is what they have defined, like you should have a strong password policy to the user. Then next, enable the MFA for the user. We have seen like multi-factor authentication is always better than a single factor, so we should enable that. Then use roles. So like we have seen, rather than keying in the credentials within the application, use roles wherever possible. So for having access for services like EC2. Then delegate by using roles. Yeah, again the same. Instead of providing credentials, you can use roles, rotate the credentials, and remove unnecessary. So using this credential report, etc., you can perform all this and use policy conditions for extra security. So in our policy, we have provided. Let me show you here. So this is our policy where we have told if AWS, let's say AWS, and let's say we give here our account name. We can even give that. So what this means is like any particular service or sorry, any particular IAM user within this particular account, they can access these buckets. But along with that, you can also add conditions like say, let's say for example, we are having a permission for put object. So what this means is we are going to allow this particular user to upload objects into this S3 bucket. We can add a condition stating that if the incoming put object is not a HTTPS request, which is nothing but it is a SSL protected, then you can deny it. So by this way, you will always have a secured upload of files. So you can use such conditions so that it will be furthermore you can restrict the permissions for other users. So and final one is monitor activity. Yeah, so we have seen our advisor, access analyzer, and credential report. So using these services, you can monitor the IAM users and what access. So you keep regularly monitoring it and take actions wherever necessary. So this is on IAM, and now we'll move on to the second topic for today, that is shared responsibility model. So the shared responsibility model, say we have migrated our application to cloud. So that doesn't mean that by default it is secure, and say AWS or any other cloud service provider will be in charge for all the security of the application. There are certain part of application in which the cloud service provider, that is AWS in this case, is responsible, and a certain part it is a customer responsible. So that is what this shared responsibility model mean. So this is a generic shared responsibility model wherein AWS takes care of the infrastructure it provides. Say we know the global infrastructure contains regions, availability zones, edge locations, etc. And so the data centers and their facility, or say the cooling, other hardware facility, everything to those particular data centers is taken care by AWS. And also it is providing services, say EC2, S3, all those services. So the software, say our console or CLA or all other software to all those services, that is also taken care by AWS. So this is what they call as security of the cloud, which is nothing but security of the cloud infrastructure. So that is taken care by AWS, and as a customer, we are responsible for security in the cloud, which is nothing but whatever you are kind of deploying within the cloud or whatever you are creating within the cloud, that is responsibility of the customer. So what will happen? So customers should take care of the encryption, say data encryption at rest, data encryption in transit, and say firewall configuring security groups, web application firewalls, and other required firewalls. And if you are using an EC2 instance, then you are responsible for selecting the guest OS. Say in the first step, we would have selected whether it is a Linux AMI or Ubuntu or whatever AMI. So though managing or using managing that particular AMI, it is your responsibility. And next comes the identity and access management. So creating the user and providing only the required permissions to it, and whatever applications you're deploying on top of it, and the data from within those application used. So all these are the responsibility of the customer. But this demarcation is not kind of static. Say for all occasions, we'll not say, okay, only AWS is responsible only until infrastructure, and rest of the things should be taken care by customer. But it actually varies depending upon the service model which we use. So we know that there are three types of service models: infrastructure as a service, platform as a service, and software as a service. So here, depending on the service models, the ownership or the shared responsibility varies. Whatever we have seen in the previous slide, it is applicable for infrastructure services. Here we'll go with the example of EC2. So in EC2, so the AWS will take care of the underlying infrastructure, but you need to select what AMI is needed for it, and what is the configuration, whether it is a T2 micro or whether it is a compute optimized, memory optimized, and how many CPU, how many RAM, how many storage you need. And once you say, select the configuration, you are also responsible for, say, high availability of that particular application, because AWS will say provide a availability zone specific availability zone redundancy, but it is up to us to use the multi-zone architecture and have the application disaster recovery ready. So all these things should be taken care by the customer. So in infrastructure as a service, so the customer responsibility will be higher than AWS. Next, if we move to container service, which the AWS calls, which we can relate to as a platform as a service. So here AWS takes some more responsibility to them, but some are left with the customer. We can go with an example of RDS, relational database service. So wherein you will not know what is the underlying infrastructure that is being handled, that will be done by AWS, but you need to configure. Say, I need a D3 large instance for my database, and it needs to be deployed in this particular VPC, and it should be having these security groups. So like these configurations you will specify, but AWS will take care of, say, the high availability, backup management. So all these things will be taken care by AWS. So this is on container services, and managed services are nothing but, we can call it as a software as a service, wherein AWS takes care of end to end on everything. You no need to even configure anything. So we are just responsible for the placing the data or using the data within that service, and the encryption for those service. A classic example is the S3 service, which you have seen, where you will just upload the documents into that particular, you'll create a bucket and upload documents into it or objects into it, and you can encrypt it, and you can have lifecycle, etc. All those things you can do, but you no need to worry about if this particular bucket is not available, what I will do, or if this particular file is not available, uh, what can I do, because all those things will be taken care by AWS themselves. So these are the shared responsibility model. And as you can see, as we go from infrastructure services to manager services, our customer responsibility becomes less, but at the same way, it is less customizable, because we'll not be having access to the underlying infrastructure or anything as such. So it will, you cannot customize to your own need. So if you are fine with whatever that is being offered by AWS, then we can use it. Yeah. So this is on AWS shared responsibility model. And yeah, if you have any questions, please put it in the chat, and we can take it up. And yeah, that's all the presentation from me. Over to you, Vivek. Vivek, you are unable to hear you.
Oh, sorry. Yep, we have got a couple of questions from the users. So Let's try to take it one by one.
Sure.
Yep. You'll be seeing this questions on your screen, so you can stop sharing your screen and jump back to our studio.
Yeah, sure.
Okay, great. Let's go for the first question. So it's from a Twitch user. So he's asking, what are you using more often? Is it AWS Manage Policy or Customer Manage Policy?
I would say customer managed policy. The reason being, like I mentioned, should have a least privileged access. So customizing particular access is more effective than a managed policy. So we'll go with the managed policy for a particular application usage. And AWS policy where we use is say for we have SSO in our organization, so we have a read-only access for that. So in that case, we'll go with the managed policy where we can have access to all the accounts and services.
Okay, that sounds good. So let's go for the second question. I guess it's from the same user again. So, can I be an administrator or root force to use an multi-factor authentication for other users? So, is it possible to enforce that for other users?
Yes, we can do that. We have something called as SCP or Service Control Policy, which will be part of an organization service, where you can define that only if a user is multi-factor authenticated, then they can be able to log in. If not, they wouldn't be able to do that. That is possible.
Okay, great. Okay. I think that answered your question as well. So, one more suggestion. I guess your video is seems to be frozen. So either you can turn off your camera or you can turn it on and off to make sure that it works.
Yeah, better I will turn off. No problem.
Yeah. Okay. No issues. Yep. We have one more question from Karthik, who is asking, will our access keys will be saved somewhere?
No. Say when a particular, say your administrator creates your access key and he shares with you, then the administrator will never save it. So you will be using it. So if you lost it, the administrator will then create a new access key for you. But whatever current, and he will mark the existing access key as inactive. So it will not be saved anywhere.
So it should be an responsibility of the developer to
Individual.
keep the access key safe. Okay.
Yeah.
So the next question is, what are the main differences between a CLI and AWS Shell? So
Yeah, so I would say a difference is still like we have mentioned. So it comes out of the box where you can browser based, you can access the services. But there are many core developers, I would say, where they want to kind of just use the programmatic access and they will install whatever required by them, so that they don't need to go for a browser based CLI. So that's where the usage between CLI and shell comes in place.
yep, that sounds I actually prefer using CLI for most of the installations and stuff. It's pretty easy as well.
Yeah.
And yep, I think this seems to be the last question of today's session. So why JSON policy for S3 had two resources like bucket name and bucket name? So I guess it had uh, one with and without the T, I guess. Isn't the second version of the bucket name enough to cover all the cases?
Okay, so usually S3 we can see there are two level of access. One is a bucket level access and another is an object level access. So say for example list bucket, these are all a bucket level access where you will just provide the ARN as a bucket name. But wherever you are specifying object level access like put object, get object, etc., you need to provide that slash asterisk so that that particular policy user is able to access whatever within that bucket. So that's why there was a two resources specific there.
Okay, that's seems reasonable. So we have one more question again. So how can you learn and improve using CLI? So I think I can take this particular question. So it comes with the practice, and it also depends on how flexible you are using CLI. So most probably, I use my local console and local development environment, and I prefer installed CLI and used to execute the commands. But if you're more moved towards portal and using a console there, then it's better to use a browser-based AWS shell, which already has most of the presets and installed libraries in there. So to improve, coming back to your again question, how to improve it? So by practice, and you can always refer to the documentation from the AWS, and it has all the commands necessary for you to execute. And and also the Twitch user says that your thanks a lot for the clarification, and you answered his question and cleared his doubt. So thanks again. And there is one question from Pubalan, who is very active user for our bootcamp. So can two IAM users access the same resource simultaneously, and even if they do, how the changes are reflected, or is there any priority is there in the IAM?
Okay, so from an IAM perspective, there isn't any precedence or priority, but based upon the individual resources, it happens. Say, for example, S3, it is kind of an immediate consistency where immediately whatever changes you're doing, it will be reflected. But in case of other services like RDS, it may be eventual consistent, where one user changes may take time to reflect, and within that, if another user updates, so that may get reflected. So it all depends on the services that's being used, but from an IAM perspective, there isn't any such priority.
Yep, that's a crystal clear answer, I guess. So I guess Pubalan, your question gets resolved. So I guess most of the users actually enjoyed today's session, and most of them actually thanked you for very good clarification and explanation. So kudos to you, speaker, as well. So I think if you have any more questions, we have a couple of minutes before we wrap up. And even if not, you can drop in our Slack channel, and you can find our invite on the screen to join our particular Slack channel, where you can ask the questions directly to the speaker. So let me finally conclude today's talk. So, yep, I guess my screen is visible. Yep. So, thanks everyone for joining the second episode of AWS Bootcamp of Cloud Practitioner by AWS User Group Madurai. So, just to conclude, thank you. We want to thank the speaker who actually made some effort, and also we appreciate that this is the first time he's presenting a session to a public, and it was really amazing, and the demo walkthrough was really excellent. And coming back to our user group, the main motive is we learn together, we contribute and grow together. So if you have any ideas, or if you want to learn something, but you also want to contribute in any way that you prefer, we are actually open. So if you want to do a podcast, or you want to do conduct quiz competitions, or you want to do something, anything that is related to AWS, please do reach out to us. We give the platform, and we give the content, and all the support, and you can create and be a content creator in our platform as well. So why you have to join our community is like we have an amazing networking with AWS experts and community members, and most of them have your objective of learning AWS from scratch. And we have special access to AWS content and event updates. We have specialized channels which is only for certifications, preparation, and study groups. So if you really want to have a motivation to study, you can hop into our Slack channel. And also we have amazing swags, vouchers, and goodies which comes from time to time from the contest we conduct. So stay tuned and keep engaging with us. And of course we engage with a lot of colleges and startups and companies, so you can look out for the job openings which being listed down in our Slack channel. So this is our invite link, and you can join right away, and do say hi in the introductions channel so we can know more about you. And these are our other social media channels. So we are available in almost every single social media. It's at the rate AWS UGMDU. So until then, stay safe and look out for the third episode of AWS Cloud Practitioner Bootcamp, which happens on Tuesday, the same times. So we conduct our bootcamps episodes every Tuesdays and Thursdays. So stay tuned at for next session on Tuesday at 5 p.m. IST. Until then, take care and bye.